Okay, Algebra 2 students, this is section 8.3. Remember, I skipped 8.1, and yesterday, or whenever, we did 8.2, and 8.2 was on parabolas, and now this is on circles. So a circle is the set of all points x, y in a plane that are equidistant from a fixed point called the center of the circle. The distance r between the center and any point on the circle is the radius. So two big pieces of information we need for a circle is the center and the radius. Now, you'll notice that I also put this up here. This is a snippet out of your textbook. It says the standard form of the equation of a circle with center at 0, 0. That's an important part. And radius r is as follows. X squared plus y squared equals r squared. Now, interestingly enough, this section coincides with geometry, section 10.7, and it actually goes a step further with centers that aren't at 0, 0. So these are falling on the same week for us. So some of you guys that are in both classes, this will actually be a little easier, I think, than the section 10.7 from geometry. So all the ones we're doing today for circles have this basic formula, but the center is at 0, 0. Okay? Center is at 0, 0. That's extremely important. So all the centers are at the origin. Okay? So what we need is an x squared. We need a y squared. Those have to be a plus between them, and then equals r squared. So again, your radius is r. Okay? All right, so these are pretty straightforward. If you look down at this example, it says x squared equals 25 minus y squared. All you have to do is add the y squared over. So this is your basic equation. So then r squared equals 25. So r is 5. Okay, so again, it's centered at 0, 0. And all of these is 5, 5, 5, 5. Okay, and you get your radius. So pretty straightforward. Now, writing an equation of the circle. On these, if they give you a point that lies on the circle, you have to find the distance between the center 0, 0 and the point, whatever the point may be. In this case, the point was 6, 2. But you have to use the distance formula. Okay? If you remember, let me remind you what the distance formula looks like. Distance formula between 2 points is x1 minus x2 squared plus y1 minus y2 squared, and then the square root of all of that. Okay, so that's the distance formula. Okay, so the distance is actually going to be our radius. Okay, so actually let me back up here. Radius must be the distance between the center 0, 0 and the point, whatever point it's on the circle. Okay, so they use the distance formula, find the radius, and then they plug it in to get the equation of the circle. Pretty straightforward. So these first 3 exercises for us to do, I've actually added a page here to your notes so that I've got some room to graph these. So it says graph the equation, identify the radius of the circle. Okay, so again, I added some graph here. So the first one, let me write up the equations for each of these first. We have x squared plus y squared equals 16. Well, that means 16 is your r squared. So if r squared equals 16, then r is the square root of 16, which is 4. Okay, so if I'm graphing this, here's my center. All of these centers are at 0, 0. I'm going to count over 4, up 4, to the left 4, down 4. This, I kind of suck at drawing, but you all get the idea. This is my circle. Okay, I hope that makes sense to you. Let's do the next one. The next one, the equation they gave us was x squared minus 81. Nope, sorry, x squared equals 81 minus y squared. I apologize. So what we have to do is rearrange, okay? Pull the y squared over. So this is x squared plus y squared equals 81. Okay, now this is my r squared. So if r squared is 81, then r is the square root of 81, or 9. Okay, now again, my center is at 0, 0, and I'm counting over, left, right, up, and down 9. Let me just say that. 3, 4, 5, 6, 7, 8. I think all of these are by 10, so I'm just going to go one in. Okay, so this would be my circle. Okay, that one's a little better than my red one. Not great, but okay, let's do the third one here. Third equation was y squared minus 9 equals negative x squared. Okay, well, we need to do a little finagling here. So I'm going to pull the x squared to the left and pull the 9 to the right. So I'm going to end up with x squared plus y squared equals positive 9. So again, that 9 is my r squared. So if r squared equals 9, then r is the square root of 9, or 3. So again, my center's at 0, 0. I'm going left 3, up 3, right 3. Actually, I said left and right backwards, and down 3. This is my circle. Okay? I hope that makes sense. So again, you need the x squared plus the y squared by itself on the left. You need the r squared by itself on the right side of the equation. Okay? Now, let me go back and look at the last one at the bottom of that page. It says, write the standard form of the equation of the circle that passes through 3, 2, and whose center is the origin. So again, we are finding distance between the origin 0, 0 and 3, 2, and that is going to give us our radius. Okay, so radius equals square root of 3 minus 0 squared plus 2 minus 0 squared, square root of 3 squared plus 2 squared is the square root of 9 plus 4, which is the square root of 13. So that's my radius. Okay, the distance. Let me see if I can change this. I noticed my dead spots here. Okay. Now, plug them in the formula. Remember, your basic formula is x squared plus y squared equals r squared. So for us, that is x squared plus y squared equals root 13 squared. Well, remember what happens when you square a square root, they cancel. So we are left with x squared plus y squared equals 13. That would be my final answer. Okay, I hope that makes sense to you. Okay, now let's go to the back side of our study guide. Now, when you're finding an equation of a line tangent to a circle, you guys are either in geometry now or have taken geometry in the past. And I want to point out a sentence here. A line tangent to a circle is perpendicular to the radius at the point of tangency. Okay, so in this drawing, if this is my radius, that has to be perpendicular. Okay, any tangent line is perpendicular to the radius at the point of tangency. Now, let me also remind you That perpendicular, remember this is the symbol for perpendicular, the upside down capital T. Perpendicular slopes are negative reciprocals of each other. Okay, that's another piece of information you need to remember. Perpendicular slopes are negative reciprocals of each other. So for instance, they're trying to find the slope m from this point to the radius, okay, because that's going to give them the slope of the radius, or from that point to the center. I apologize, your center 0, 0. So remember, slope 2 is y2 minus y1 over x2 minus x1. So let's remind ourselves of that as well. So we find slope, so 3 minus 0 over negative 1 minus 0 is negative 3. So that's the slope of the radius. Okay, so the slope of the tangent line is the negative reciprocal of negative 3, or positive 1/3. So then they get to here, which is the point slope formula, another formula. Let me remind you, the point slope formula for a line looks like this. It's y minus y1 equals m times parenthesis x minus x1. Okay, let me remind you here that the x1 and the y1 are point coordinates. And of course, the m is slope. Okay, the x1 and y1 are point coordinates and the m is slope. So that's where this came from. Okay, so y minus 3 equals 1/3 x minus a negative 1. And then we solve it and put it in slope-intercept form. Okay, so let's look at, actually, let's look at a couple of these examples. Let's look at number 5. Okay, and then I'm going to go back and we'll talk about number 6. But number 5 says write an equation of the line tangent to the circle x squared plus y squared equals 20 at the point 2, 4. So what that means is, I'm just going to kind of quickly draw this. So at the point 2, 4. So this point is on the circle. Whatever, this is the point we're talking about, the point 2, 4. Okay, and they want the equation of the line that's tangent to it. Well, that's my radius. My picture's not very good, but that would have to be perpendicular. Okay, so first thing I need to do is find the slope of the radius. Okay, the slope of the radius. Okay, I'm going to call this m and then a little rad kind of subscript. Okay, it's going through the point 2, 4. So that is going to be 4 minus 0 over 2 minus 0, which is 4/2 or positive 2. Now, remember, we're finding the slope of the radius. That's between the point 2, 4 and the origin at 0, 0. Okay, those are the 2 points we're using, 2, 4 and 0, 0. So that means the slope that's perpendicular. The slope that's perpendicular, again, I'm using m, but I'm using my little perpendicular symbol for the little subscript here. So the slope that's perpendicular to positive 2 is negative 1/2. Okay, it's the negative reciprocal. So the negative reciprocal of positive 2 is negative 1/2. Now I use the point slope formula. Okay, point slope formula. Okay, I am using the, well, let me do this. I'm using the slope of the perpendicular there, the negative 1/2. My x1 is going to be 2. My y1 is going to be 4, the actual point that we know is on that tangent line. Okay, so now I'm using point slope formula. So y minus 4 equals negative 1/2 times x minus 2. Well, this is y minus 4 equals negative 1/2 x plus 1. Okay, remember this 1/2 has to be distributed, or the negative 1/2, sorry. Add your 4 to move it over. So y equals negative 1/2 x plus 5. That right there is the answer to number 5. Write an equation of the line tangent to the circle at a particular point. We have to find the slope of the radius. Then we have to find the perpendicular slope to that, and then use that point that they gave us, the 2, 4, in the point slope formula. Okay, and then solve for y. Okay, now back up here, look at example 4, store delivery. A furniture store advertises free delivery within a 50-mile radius from the store. If a customer lives 28 miles east and 41 miles north. Now, 28 miles east and 41 miles north is kind of like the ordered pair, right? That's what they show there. The ordered pair, 28, 41. Okay, that's this. So it says, if they live there, does the customer qualify for free delivery? Well, what you're really checking is the radius. Okay, if you're going to draw a circle around that point, is that radius less than 50? Okay, now they actually keep it in the squared form, so you don't have to worry about square roots. But this is what you're asking yourself. Okay, does your x squared plus your y squared, is it less than 50 squared? Okay, remember that's the basic form of your circle, right? X squared plus y squared equals r squared. So in our case, we want our x squared plus y squared to be less than our r squared. Okay, so with that in mind, let's go down here and look at number 6. It says rework example 4, okay, which reworking example 4 means free delivery within 50 mile. I should say 50-mile radius. Okay, free delivery within a 50-mile radius. So determine if a customer who lives 30 miles west and 41 miles south would qualify for free delivery. Okay, so 30 miles west and 41 miles south would be the ordered pair, like negative 30, negative 41. Okay, and again, of course, that's a dead spot. Now, what we have to do then is put it in the x squared plus y squared has to be less than r squared. Okay, so this gets us negative 30 squared plus negative 41 squared. Is that less than 50 squared? Okay, that's what we're asking ourselves. That's why I've got the little question mark there. So negative 30 squared is 900. Negative 41 squared is 1681. Okay, is that less than, question mark, 2500? That's what 50 squared is. Okay, well, if you add those up, no, it's not. This is 2581. 2581 is not less than 2500. Okay, so would a customer qualify for free delivery if they live 30 miles west and 41 miles south? That would be a big fat no. Okay, so that's what you're doing. Okay, I hope that helped. Let's look at our practice A. Okay, practice A, match the equation with its graph. All of these circles are centered at 0, 0, so it's simply a matter of picking the right radius. Okay, I'm not even doing any on 1 through 3. Okay, you all can do those. 4 through 9 says graph the equation, identify the radius of the circle. I'm going to do number 7. Okay, so remember, basic form, actually let me put that up here. Basic form of a circle, remember, is x squared plus y squared equals r squared when it's centered at origin. When the center is 0, 0, and the radius is r. Okay, that's the basic form of a circle. Remember that. Okay, so this one, this, remember, is your r squared. So that means r equals square root of 12, which is 2 root 3. Okay, so first of all, in the directions, let me scroll back up. It says identify the radius of the circle. So that's the first thing. This is the radius, 2 root 3. Okay, as a decimal, notice the squiggly brackets. As a decimal, that is about 3.5. So when I go to graph this sucker, it'll be a little easier to graph there. So my center's at 0, 0. Okay, my points here, my radius is 3.5. So just inside the 4. Left, right, top, and bottom. Just inside the 4. And we're counting by 2s. Okay, you can see that on the graph paper there. Okay, so that would be my circle. Okay, hope that's all right. Moving right along. Let's look at number 12. Write the standard form of the equation of the circle with the given radius, whose center is the origin. So again, this is my r. So I've got x squared plus y squared equals root 10 squared, because that's my r, right? Well, if you square a square root, of course, they cancel. So it's just x squared plus y squared equals 10. Hope that makes sense. Next section, write the standard form of the equation of the circle that passes through the given point and whose center is the origin. Okay, so again, let's do 15. We first have to find the radius. Okay, your radius is going to be the distance between 0, 0 and 3, negative 2. Okay, those are the 2 points that we're trying to find the radius between, because that's the center of the circle and a point that lies on the circle. So we are going to have 3 minus 0 squared plus negative 2 minus 0 squared. Well, that is the square root of 9 plus 4, which is square root of 13. I hope you all can see that over the shading there. So now we have to find the equation. So x squared plus y squared equals root 13 squared. So that is x squared plus y squared equals 13. Again, the square and the square root cancel each other out. Okay, x squared plus y squared equals 13. Okay. Number 16, write an equation of the line tangent to the given circle at the given point. Okay, now, again, what we need to know, first of all, is a line that's tangent to the circle is perpendicular to the radius. So first we got to know the slope of the radius. Okay, so the slope of the radius, okay, again, I'm using this along with the center of 0, 0. That's what I'm finding the slope of. Okay, so 3 minus 0 over 2 minus 0, which is just 3/2. So that means my perpendicular slope is negative 2/3. Okay, if the slope of my radius is 3/2, my perpendicular slope is negative 2/3. And in addition to my perpendicular slope, okay, so I need this, and I need that the point the line is going through, x1 is going to be 2, y1 is going to be 3. Then I need the point slope formula. Okay. Use point slope formula. So y minus 3 equals negative 2/3 parenthesis x minus 2. Now again, that negative 2/3 has to be distributed, right? So we've got y minus 3 equals negative 2/3 x plus 4/3. Negative 2/3 times negative 2 is like negative 2 over 1. Okay, so positive 4/3. Then add your 3 to move it over. When you add 3, it's like adding 9/3, right? You got to put it in fraction form. So this is negative 2/3 x plus 4/3 plus 9/3 is 13/3. That would be the equation of the line that is tangent to the given circle at the point 2, 3. Okay, notice that the radius length had nothing to do with our calculations. We didn't need, just a reminder, we didn't need this 13 for anything. We don't care what the radius length is. We need the radius slope. Okay. All right, and number 18 is one just like we did. A radio station has a broadcast radius of 40 miles. Your house is located 32 miles west and 21 miles south of the radio station. Is your house within the broadcast range? Okay, so once again, here's your point. Your point is going to be negative 32, negative 21, and your radius is going to be 40. Okay, you have to put that into the x squared plus y squared. You're checking to see if x squared plus y squared is less than r squared. Okay, that's what you're checking, and I'll let you all finish that off. Okay, this concludes section 8.3. Again, very similar to geometry section 10.7. It's actually a little easier, I think, other than maybe finding the equation of the tangent line, but pretty straightforward. Next week, I will be covering 8.4 and 8.5. Okay, I do want you guys to be exposed, for those of you that are choosing to do this, to conic sections. So that's going to help you a lot for those of you all going on into trig. So have a good one. Take care.